Hey everyone, welcome back to the channel. If you're new here, get ready to have your mind absolutely expanded as we tackle one of the biggest questions in existence. How big is the universe? Before getting into the video, subscribe to our channel for more interesting videos like this. Picture this. You're standing on Earth, looking up at the night sky. Those twinkling stars seem endless, but they're just the beginning. The numbers we're about to explore are so enormous that our brains literally struggle to comprehend them. Yet they're grounded in real-time astronomical data from telescopes like Hubble, James Webb, Planck, and ongoing surveys in 2026. From the observable universe's staggering 93 billion light-year diameter to the mind-boggling scale of galaxies and beyond, today we're breaking down the latest numerical facts with precise values so you can truly grasp the incomprehensible vastness of everything. Stick around because by the end, you'll never look at the cosmos the same way again. Let's start with the basics. The universe as we know it began with the Big Bang approximately 13.8 billion years ago. That's 13,800,000,000 years. This age comes from precise measurements of the cosmic microwave background radiation by missions like Planck, combined with data from the Hubble Space Telescope and JWST. The current best estimate for the universe's age is around 13.8 billion years, though slight tensions in the Hubble constant, measuring expansion rate at about 67 to 74 kilometers per second per megaparsec, keep refining it. Now, how far can we actually see? The observable universe, the spherical region from which light has had time to reach us, has a current diameter of about 93 billion light-years. That's 93 billion light-years across. One light-year is roughly 9.46 trillion kilometers, or 5.88 trillion miles. So the full diameter in kilometers is an insane 8.8 times 10 to the 26th meters. The radius is approximately 46.5 billion light-years in every direction from Earth. Why is it so much larger than 13.8 billion light-years? Because space itself has been expanding since the Big Bang. The light we see from the farthest regions left its source when the universe was much younger and smaller, but cosmic expansion has stretched the distances dramatically. To put that in perspective, if the observable universe were scaled down to the size of Earth, the distance across it would still boggle the mind. Our entire solar system, out to Neptune at about 30 astronomical units, or 4.5 billion kilometers, would be microscopic. The Milky Way galaxy, spanning roughly 100,000 light-years, would be a tiny dot. And there are an estimated 2 trillion galaxies in the observable universe. That's 2 trillion galaxies. Each galaxy, like our Milky Way, contains around 100 to 400 billion stars. Multiply that out, and you get numbers like 10 to the 22nd power to 10 to the 24th power stars total. More stars than grains of sand on every beach on Earth, by a huge margin. Our own Milky Way is about 100,000 light-years in diameter, and contains at least 100 billion stars, with recent estimates pushing the stellar count higher thanks to Gaia and other surveys. The solar system sits about 26,000 light-years from the galactic center. The nearest star, Proxima Centauri, is 4.24 light-years away. The Andromeda Galaxy, our nearest large neighbor, is approximately 2.5 million light-years distant. Yet these are tiny steps in the cosmic ladder. Zooming out further, galaxy clusters and superclusters form vast cosmic webs. The Virgo supercluster, which includes our local group, spans over 100 million light-years. Even larger structures like the Laniakea supercluster stretch to 520 million light-years across. But the observable universe encompasses all of this and far more. Its volume is roughly 4 times 10 to the 32nd power cubic light-years, or about 3.57 times 10 to the 80 power cubic meters. If you tried to count all the atoms in the observable universe, estimates put ordinary matter at around 10 to the 80 particles, but that's only about 5% of the total energy mass content. Dark matter makes up approximately 27%, and dark energy approximately 68%, the mysterious force driving the accelerated expansion we measure today at rates that continue to refine our models. The expansion itself is key to the size. The Hubble constant, currently hovering around 70 kilometers per second per megaparsec on average, with tensions between early and late universe measurements, tells us space is stretching. 1 megaparsec is 3.26 million light years. This expansion means distant galaxies are receding faster the farther they are, some at speeds approaching or even appearing to exceed light speed due to the metric of space-time itself, not violating relativity. Beyond the observable universe, we simply don't know. The entire universe could be infinite, or at least thousands of times larger than what we can see. Inflation. Theory suggests the full cosmos inflated rapidly after the Big Bang, making the observable part just a tiny bubble in something vastly bigger, potentially 10 to the 23rd power times larger or more in some models. We may never directly observe beyond the cosmic horizon, about 46.5 billion light years away, because light from there hasn't reached us yet and never will due to ongoing expansion. Consider the scale another way. If you could travel at the speed of light, 300,000 kilometers per second, or 186,000 miles per second, it would take you 13.8 billion years to cross the distance light has traveled since the Big Bang. But because of expansion, you'd never reach the current edge in a human lifetime or even the universe's current age. A photon emitted at the Big Bang has been traveling for 13.8 billion years, but is now 46.5 billion light years away. Recent 2025 to 2026 data from JWST and other observatories continue to refine these numbers. JWST has imaged galaxies forming just a few hundred million years after the Big Bang, pushing our understanding of early structure formation. The cosmic microwave background gives us a snapshot from 380,000 years after the Big Bang, when the universe was about 0.003% of its current age. The sheer scale inspires awe and humility. Our planet Earth has a diameter of just 12,742 kilometers. The Sun is 1.39 million kilometers across, over 100 times Earth's diameter. Yet the Sun is one of hundreds of billions in the Milky Way, which is one of 2 trillion galaxies. If you stacked all the grains of sand on Earth, estimated at 7.5 times 10 to the 18th power, it wouldn't come close to the number of stars. This vastness raises profound questions. Are we alone? How many habitable planets exist? With trillions of galaxies and sextillions of stars, the statistical odds favor countless worlds, though we're still searching with missions like Kepler's successors and Roman in the near future. As we wrap up, remember that every new telescope and observation refines these incredible numbers. The universe is not static, it's dynamic, expanding, and full of wonders we're only beginning to grasp. If these mind-blowing scales, the 93 billion light-year observable diameter, 13.8 billion year age, 2 trillion galaxies, and the mysteries beyond, left you speechless, smash that like button. Share this video with friends and family who love space so they can wrap their heads around it too. Subscribe for more fascinating, fact-packed videos exploring the cosmos, and hit the bell icon. Comment below. Which number shocked you the most? The diameter, the number of galaxies, or the idea of infinity? What other cosmic scale questions do you want answered next? Thanks for watching, and keep looking up. The universe is calling. The universe is not just bigger than we imagine, it is bigger than we can imagine.